Can you all see the screen over here? Figure 5.12 and 5.13.
Yes, sir.
So we'll do this question. Example, calculate the LHF of a star whose right ascension is 70 degrees for an observer.
What is the page number?
Page number, I hope it is the same edition, 69. Celestial sphere chapter, I told you. First example over there. For an observer in longitude 47 east when GHA iris is 210. So just take out this page. When you're ready, let me know. Looking at the question, I've stopped sharing the screen, so for the question you can look in your own book. From what I have drawn, what is the first value which you can put? The question says calculate the LHA of a star whose right ascension is 70 degrees. Now LHA of the star you can start from which point?
Longitude.
From longitude.
Observer's longitude, LHA, but I don't have the observer's longitude on the screen, so I cannot start with the LHA. The star's right ascension is given 70 degrees. Can I put the star now and the right ascension? I cannot put because I don't have iris. Once I have the iris on the screen, then I can put the right ascension star. Am I right?
Yes.
Yes or no? फटाफट जवाब दिया करो. LHA I can start only from the observer's longitude. I don't have the observer's longitude right now. Reading the question. Right ascension I can put only from the first point of iris. I cannot put that because I have not plotted iris as yet. I have only plotted G, my first reference point. Read the question further. For an observer in longitude 47 east. Yes. Now I know that the observer is in 47 east. So I can draw the observer 47 east. This is 90, this is 45. So observer is somewhere here. You must always try to draw the diagram proportionately with degrees or whatever so that the orientation remains good, you know. So this is the observer. Is it correct? What I have drawn? Observer in 47 degree east longitude?
Yes, sir.
Yes.
Which is the second point? GHA iris is 210 degrees. So GHA iris from where I have to draw?
Greenwich.
From Greenwich, I have to draw 210 degrees. Which side? Which direction?
Westerly.
Westerly, very good. So I go west from Greenwich, 90, 180 and 30. So 210 degrees, I have got GHA iris. So this is my GHA iris, 210 degrees. This is my longitude, 47 degrees east. Now what is he talking about the star? Now we can come to the star. Calculate the LHA of a star. I have to calculate the star whose right ascension is 70. Right ascension of the star 70 means what? Right ascension
70 degree east of Aries.
70 degree east of the iris.
10
70 degree east of iris or 290 degrees
Yes, sir.
west of iris.
West of Aries.
So 70, this was 30, this is another 40. So this is the position of the star. Correct? Right ascension 70. I have to find LHA star. What is the LHA now? Is this the LHA star? Arc of the equinoctial or angle at the pole. This is the pole between the meridian of the observer and the meridian passing through the body. So how much is this angle LHA star?
GH Aries minus right ascension.
LHA star. GHA Aries minus
GHA of
ascension.
star.
X plus हुआ सर.
GHA of star plus observer longitude.
longitude, sir.
We will get GHA of star by subtracting GHA of Aries minus right ascension.
Okay. LHA star is equal to what was the formula?
GHA of star plus
longitude.
east and minus X west.
GHA star plus east
Plus
longitude.
minus longitude.
We are in east longitude, so plus east longitude. Correct. So what is GHA star? Here we can see GHA star is equal to
210. No, sorry.
this is GHA star is equal to
147.
GHA Aries minus right ascension. Huh? GHA Aries minus right ascension, which is equal to 210 minus 70, which is equal to 140. Yes or no? So LHA star is equal to 140 plus 47 is equal to 187 degrees. Have all of you done this and understood, or you have any doubt? See, it is so very simple. Once you understand the diagram, you draw the diagram. Either you solve directly here, you can do the formula also. Without the diagram also, I can do the formula. But if you have a diagram, the perspective is very, very clear. The board is visible, the book is in front of you. See figure 5.12 in the book also. It is same, figure 5.12. Take half a minute to think, look, draw, and let me know if you have any question. Then I will go to the next one. Anyone has any question, ask now. No questions? Everyone clear?
Yes, sir.
Yeah, LHA star.
Okay. There are 3-4 examples given over there, which are very clear with the diagram and everything. You must practice that. Go down to exercise 5. We will do question number 1. Are you there? Question 1, exercise 5. Okay. Just read the question. Anyone can read loudly?
The planet Venus
Sir,
was
the
on the
planet
meridian of
Venus.
the planet Venus was on the meridian of an observer in longitude 62 degree east. If the right ascension of Venus at that instant was 87 degree, find the GHA of star, the SHA of which then was 162 degree.
Very good. It's a good question which we must do so that everything is clearly understood. Okay, so once again we have the equinoctial diagram. We have the pole in the center. Whether you write or not doesn't matter. We have a starting reference point and we will plan our thing from here. So which is the first value which I can put? The planet Venus was on the meridian of an observer in longitude 62 east. If the right ascension of Venus at that instant was 87, find the GHA of a star, the SHA of which then was 162. So which is the value I can put first, gentlemen?
Longitude.
Longitude 62 east. Very good. Observer 62 degrees east. What else can I do over here? The planet Venus was on the meridian of an observer, which means that Venus is also here. Along with the observer, the Venus is also here because Venus is on the meridian of the observer. Yes or no? Venus is going around the pole. The Venus may cross meridian of Greenwich. The Venus may cross first point of Iris. The Venus may cross the meridian. Observer, you are standing. You are on the ship somewhere and you see Venus crossing your meridian. So both are on the same meridian, observer's meridian. This point is clear with everyone? Okay.
Yes, sir.
Second is, if the right ascension of Venus at that instant was 87. So from where do I have to measure 87?
So from
Venus is 87 from
west.
Sir, Venus to westerly.
Venus is 87 degrees from which point? When we say right ascension of Venus, which point are we referring to? Which is the reference point?
So GHA Aries.
Right ascension.
From Aries.
From
Aries, first point of Aries. Somebody said GHA Aries. Sidereal our angle is west of first point of Iris. Right ascension is east of first point of Iris. So when he's saying right ascension, Venus is 87. That means Venus lies 87 degree to the east of first point of Iris. Correct? If 87 she lies to the east, so 87 minus 62.
25.
25. So 25 degrees here if I draw first point of Iris. Am I right or am I wrong?
Yes, sir.
$25 plus 62 is 87. So Venus is 87 degrees right ascension from first point of Aries. All clear so far, gentlemen? Okay. Find the GHA of a star. So GHA of the star we have to measure westwards from G. The SHA of which then was 162. The SHA of which was 162. So SHA of a star 162, from where will I draw?
The GHA of Aries western.
SHA of a star was 162. We have to find the GHA of the star.
So
We
from
have to
Aries
find
to the westward,
from
160.
Aries to the westward, we have to do 162, correct? 162. So 90 and so much 162 is 180, 18, somewhere over here. Everyone can see that blue line? Yes or no?
Yes, sir.
So SHA of the star is 162 degrees. SHA star 162 degrees. What do we have to find out finally? We have to find GHA star. So what is GHA star?
187.
Sir, 187 degrees.
GHA star is equal to 187 degrees. Very good. Very good. So if you want, we can do this by formula also, we can try. What is the formula of GHA star? If you remember, considering
GHA Aries plus SHA.
GHA Aries plus SHA
SHA star.
star. Very good. So what all information do we have in the question? Maybe we'll have to do 1 or 2 more calculations to figure out. So GHA Aries is we have found out is 25. GHA Aries we found out 25 degrees, and SHA star we have 162. That of course from the diagram we have found out, but if you can work out something by whatever 2 or 3 formulas that we have, it can be easily found out. Not a big issue. But the main point is, have you understood the diagram and the positioning of all the meridians or not? Any question, gentlemen? Please ask now, because once I leave this topic, then unless we go in for revision after the course, it will be difficult to come back again and again. We are already running a little slow, I guess. I hope you are doing reading after the class at home. No questions, gentlemen? So we will go on to the PZX triangle thing now. We will go on to the PZX triangle thing. So write down this question. Let us draw a PZX triangle. Let us draw a PZX triangle. observer latitude 20 degrees north, declination star or any body 30 degrees north, LHA star 300 degrees. Let us attempt this one. All of you have written down the question. For when we are talking about latitude declination, we should be doing the rational horizon diagram. I've told you how the rational horizon diagram looks like. The observer is in the center, the zenith of the observer. There are directions north, south, east and west. So far so good. After this, guide me how to go about. First, which line we can draw?
Sir, latitude.
So equinox.
Latitude.
Yeah, we can draw the equator. Very good, but where to draw the equator? Do I
So
draw it like this, so much
Below
down,
zenith.
or a little
below
less
zenith,
down,
20 degrees below. Below
or
the
above zenith? Above zenith or no?
Sir, below 20 degrees.
Below zenith, sir, 20 degree.
20 degree below which one?
zenith.
WZ, sir.
That,
Yeah,
so
okay,
WZ.
very good. Now, you must see, in our time, you know, when we used to do this, we used to, on the line sheet, you know, we used to take 9 lines, draw the compass, make a circle 4.5 on either side, which means if you equally divide this into 9 units, then you get a very nice proportionate diagram, so the orientation remains good. So if this is 9, this is 4.5, so 20 degree would be somewhere here, correct? Latitude is 20 degrees north. So we draw the equinoctial like this. WQE. Okay. So if this is WQE equinoctial 20 degrees latitude, which is the next thing which I should draw?
Declination.
Declination.
Yeah, but I can draw the pole
The
also
pole.
just as an indication. Let us mark the pole.
Yes, sir, 20
The
degrees
pole is to be drawn where?
So 20 degrees below the north.
20 degree below north. Very good. Why?
So because our latitude is 20 degree, so we put the equinoctial 20 degree below the zenith. So this NP should be is equal to
NP equal to ZQ. Very good. Also, pole is 90 degrees away from the equinoctial. So 20 plus 70. Same thing you can. So this is correct now?
yes.
Okay, very good. I'm very glad that you people have understood. I hope everybody else is also following. Only 4 or 5 people answer all the time. Others also should participate. The other thing is the declination, and let us do the declination now. 30 degrees north. So yesterday, did you get a chance to study those 10 figures which I had told you?
Yes, sir. So
D, E, F, G, H, I, J, K, L, M, and whatever. Did you trace the path of the body north of the equator, south of the equator, less than the latitude, more than the latitude? So if you have done all that, very good. You will get a very good idea of everything. So how should the declination line follow?
sir,
One,
10,
it should be
10
parallel to WQE.
Yes, sir.
Yes, yes, sir.
So 30 degrees north, it means I should draw north of east or south of east?
Sir, north.
North of east.
North.
North of east 30 degrees. So this should be okay. 30,
10 degree
45.
below zenith. Above zenith.
Yes,
Above
sir.
zenith by 10 degree.
Very good. Above zenith by 10 degrees. This should be the path, right?
Yes.
Because the declination is more than the latitude, so the path of the body will be something like this. Beautiful. Yeah. The body will rise here in the east. Declination 30 north. So rising bearing will be what? Any idea?
So
The
less than
observer at
90.
Z, if he takes a bearing at the time of rising, what should be the bearing?
So 60.
60 degree, very good. And what will be the setting bearing?
So 300.
300.
300, 310.
And in between, what will happen to the bearing? In between, what will happen to the bearing? 60. In between, what will happen to the bearing? We have to see. The bearing keeps changing. From here, when I observe,
So it will start decreasing till observer meridian, then start increasing.
you have to draw a vertical circle and then you will know exactly. 60, for some time it is increasing, then again it is decreasing, going inside. Yes? At this point, maximum azimuth maybe 63, 64. And again, when it comes here, it goes inside, no? 55, 50, 45, 40, 30, 20, till it comes on the observer's meridian. What is the bearing on the observer's meridian?
0.
North.
180.
180.
180.
180, sir.
180 if the body would have crossed meridian south of the observer. If the declination would
Right
have been
now it
less
is
than the
0.
latitude,
So 150 years.
you see, if the body's declination would have been less than the latitude, the body would have come like this, crossed south of the observer. When it would have crossed south of the observer, then the bearing
Then
would have
it-
been south.
180.
But now it is crossing north,
0.
so the bearing will be 0. Somebody said 180. That's why I was trying to explain again. You see, if the... Okay, let me draw one more line so that it's clear, but I hope you don't get confused with me. If the declination would have been less than the latitude, then the body would have crossed like this, in which case, when it comes on the meridian, it will bearing south, because you are going to take the bearing when you are at Z, so the bearing will be south. In this case, the bearing is north. Clear? There are some tricky questions also later on, maybe phase 1, or I don't know whether you will do or not. If you will notice that in this green line, the bearing is never 90 or 270. The bearing is never 90 or 270. But if the declination is less than the latitude, there will be a time when the bearing will be 90 and the bearing will be 270. So when little bit of such information is given in the question, you can trace the path of the body and you can come to the conclusion, yes, if the bearing has been east, it means the declination of the body is less than the latitude. So these are the type of things which you will figure out, and also the latitude is the same name. North latitude, north declination. Otherwise the bearing will not be east. For a south declination body, it will go like this. Bearing will never be east or west. It will be more than 90 and less than 270, and here it will be 180. So 180 for this also, for 180 for this also, because both the bodies are south of the zenith, but the declinations are different. So the body itself is defining, telling you how I am moving, and you can decide for yourself whether my declination is north or whether my declination is south. If it is north, It is less than the latitude, or it is more than the latitude, or is it circumpolar? If there is upper meridian passage and if there is lower meridian passage also, then the body is going to be circumpolar. Yesterday we discussed all this, and I had told you to study all those diagrams also. So you must be having a fairly good idea by now. If not, you can ask questions. I will explain to you. In the meantime, let us continue with our quest for the PZX triangle. Okay. So we are going ahead with our rational horizon diagram. So far, very rightly, all of you have pointed out to me where I should draw WQE, where I should draw the declination circle, where I should put P. So latitude is done, declination is done. Now we have to fix the position of the body. Where is it? Is it here at the rising point, or is it somewhere in between? Is it near the meridian? Is it on the meridian? Has it crossed the meridian, or is it about to set? Where on the green line is the body right now? That we will come to know by the LHA or GHA or SHA, whatever. So here the equinoctial diagram is coming into play a little bit from the plan view. Whatever we saw earlier. In order to give you a clear perspective, let me make a small figure over here. Let us say this is the observer, because now you are in the center, and LHA of the body is 300 degrees. So how and where should I draw?
Easterly.
Westerly from here, how much? 180, 270, 300.
300.
Is this clear to everyone?
Yes.
Is this clear to everyone? So keeping this in mind, now you tell me where I should draw the declination circle.
सर पोल पे 300 का बनाएंगे अपने ऑब्जर्वर मेरिडियन से तो
Very good. LHA 300 degrees. So this is the observer's meridian. And ZS is the observer's meridian. 300 degree from the observer meridian going westward. If the LHA would have been 0 to 180, body would have been
वेस्टर्ली
westward.
LHA 180 to 360.
ईस्टर्ली
So 300 we will count from here. 90, 180, 270, 300. So this is the LHA 300 and the meridian passing through the body. Am I right?
Yes,
Yes
sir.
or no? Okay. So in the PZX triangle, we will try to complete the third part. From the LHA, I have got PX. Do I know the length of PX, or I do not know?
Yes, sir. 90 minus declination.
60
Very
degrees.
good.
90 minus
E-
30.
Ex is equal to 90 minus declination is equal to 60 degrees. Correct? Very good.
Yes.
Yes.
So that is the polar distance. One side. PZ, this meridian is also great circle.
Yes, sir. 70 degrees. PZ is
I know PZ also. PZ
90
also is
minus latitude.
90 minus latitude.
yeah, PZ is equal to 70 degrees. I don't know ZX. How will I find ZX? What is ZX?
So
So
2
ZX is
altitude.
90 minus 2 altitude.
90 minus true altitude. If I take the altitude by means of a sextant, if I take the altitude by means of a sextant, 90 minus the altitude will give me ZX. That is the zenith distance. So the construction of the triangle, does anyone have any doubt upon the sides and whatever we have spoken, and how we are able to construct this triangle by the data that we got, the direction of the body, the positioning of the body, the equator, how to draw a line, any line on which part of the rational horizon diagram. Have you understood this one clearly? Why we did not do the PZX triangle on this side, but we did on this side because of the LHA and these sort of things. Okay. Here I will try to tell you a little more about azimuth and amplitude, just because we have this diagram now. What is the azimuth in this case? At this point of time, what is the azimuth? As a definition, what is the azimuth? Does anyone know?
Sir, 120 in this case.
No, you have to name the angle only. You don't have to give me a
Angle PZX, sir.
angle PZX. Very good. The definition of azimuth is the arc of the rational horizon. The arc of the rational horizon or the angle at the zenith. Or the angle at the zenith. Between the observer's meridian and the vertical circle passing through the body. Azimuth is the arc of the rational horizon. In the case of our angles, we were saying the arc of the equinoctial, if you remember. But now arc of the rational horizon or angle at the zenith between the observer's meridian and the vertical circle passing through the body. So definitions also you have to remember, sometimes you get short questions. Yesterday I also told you that in a spherical triangle, if you know three things, you can solve the triangle to find out the other three. There are three angles and three sides. If you know three things, you can find out the other three by using our trigonometric formula or whatever. Now, when I'm taking a side and I've drawn the PZX triangle, two things I have got immediately. When I took a sextant altitude, I got the zenith distance. When I took the azimuth, I got angle Z. And from the almanac, I can get the GHA and the LHA. Or from the declination, from the almanac, I can get PX. So let us not talk about the LHA now because longitude is involved, so that is a DR. Let us say I took an azimuth, I got one angle. I took the sextant altitude, I got one side. And from the time on the chronometer, I checked the declination of the body and I got angle px. So I have angle z with me. I have side zx with me, and I have side px with me. If I have got these three things, I will be able to find the other two. What are the other two that I am interested in, gentlemen? What is my point of interest?
So PZ to find the latitude.
What did we set out initially in the first class? I told you, what did we set out to find by means of celestial observations?
Our own position, sir.
Our position, latitude and longitude. So PZ is a side of the triangle PZX. So if I find PZ, I can get my latitude. 90 minus
Yes,
PZ,
sir.
yes or no? I can get, no? And which is the other coordinate which I am interested in?
Longitude.
Longitude, how I will get? How I will get longitude?
Angle ZPX, sir.
Angle? Which angle?
ZPX.
ZPX, angle P, very good. Once I have angle P, I will know my LHA. Once I have angle P, I will know my LHA. And what was the formula yesterday? LHA is equal to GHA plus east minus west long. Yes or no?
Yes.
We know this formula. So if I know angle P, I know my LHA. GHA I know from the almanac. The difference will give me the longitude. Yes or no? Gentlemen, take a minute to absorb the diagram, to understand what I said. Think about it. We set out to find our position by lat and long. We have completed our journey by the PZX triangle. And now we know how to get the latitude and the longitude. Those formulas and all those things are a matter of practical navigation. We'll go into those. We don't do derivation of formulas. But theoretically, conceptually, I hope you have made myself clear and you have understood. If you have any questions, gentlemen, please ask. No one? No questions? I have been able to make myself so clear.
सर मैं एक जगह पढ़ा था कि अगर एजिमुथ मैक्सिमम हो तो एंगल x 90 डिग्री हो जाता है, वो मतलब एक्सप्लेन कर सकते?
या जब मैक्सिमम हो जाएगा तो 90 हो जाता है. It is the same thing what we did in the solar system, that elongation class. At the maximum azimuth, actually, I appreciate your reading a little ahead. We would have done that when we do circumpolar. See, I'll give an example. Whether it's here or anywhere. When it is maximum azimuth, it is a tangent to the circle. Let's say there's a circumpolar body over here. At these 2 points, the bearing is north. At this point, the bearing is maximum. From north, or from this north, it is decreasing 358, 357, and it is coming maximum over here 350, let us say, and then it is increasing. Again increasing here up to maybe 10 degrees. And then come. So this is the maximum azimuth. Azimuth is the arc of the rational horizon or angle at the zenith between the meridian of the observer and the meridian vertical circle passing through the body. Now if this is a circle and there's a tangent to it, the radius of this line will make a angle of 90 degrees.
Yes, sir.
Yeah, समझ गया ना? Yeah. So that is the theory basically behind this, which helps you solve all these problems very easily. If you understand this, then in some numericals, you know, they give you less information and you have to figure out what he's trying to say, which also we will do in the amplitude. I will explain after this a little bit about the amplitude also. Okay, very good. Does anyone have any question on the azimuth? What is azimuth? Whenever you take a bearing, it's azimuth. You are at the observer's Z point and you are taking a bearing of the body. When you take a bearing over here, this is the azimuth. When you take a bearing over here, this is the azimuth. Azimuth is measured from where?
True north.
North. So you can go like this and you can say the bearing is 330 degrees. That's the bearing. But when we are talking of azimuth, how did I define the azimuth? The angle at the zenith between the meridian of the observer and the vertical circle passing. So when we do ABC tables or we do naming of the azimuth and we do other calculations, we would say the azimuth is north 30 west. Yes? North 30 west. In this case, the azimuth is 60, which is as per the bearing also. Huh? Let us say 60 or no, not 60, should be maybe 70. Here azimuth is what? North 70 east. Strictly speaking, if I use the word azimuth, this is the way it should be mentioned. North 30 west or north 70 east. Similarly, if there is a body with a southerly declination, and there is a body here and a body there, how will I write the azimuth of these bodies? When you take out compass error, you get the bearing of the body, but when you are naming it, you are able to figure out. So let us say the bearing of this body is 160 degrees and the bearing of this body is 240 degrees. What will be the azimuth of these bodies?
So south 20 degree east and south 60 degree west.
South 20 degrees east and south
60 degree west.
180 to 100, yeah. 60 degrees west. Any questions on this, gentlemen? When we do problems on azimuth, we will understand the working better. But as far as the definition of azimuth and as far as the naming of azimuth goes, it is like this. Anyone has any question on this or no? So we have done today morning PZX triangle and we have done the azimuth theory part. After the break, I will do the amplitude. I will explain to you because since we are in that mode now, the next logical thing to explain to you is the amplitude, which I will explain. I will also explain a little bit of that 90-degree theory, angle 90 degree or side, whatever. And then we will do a little bit of twilight. So gentlemen, you can take your break now for 15 minutes. Come back at 10:15. Okay.
Okay. Thank you, sir.
Okay, sir. Thank you.
Thank you, sir.